Hello everyone, my name is Stephanie Seck, and I will be walking you through how to solve the 2005 free response question number 1. The 2005 free response question involves solving for the area between these two lines, as shown by region R in orange and region S in blue. The first place to start when solving for area between two separately graphed equations is to look for the point of intersection. The point of intersection is right here, and you can find it using a graphing calculator. I have a trusty TI-89, but any graphing calculator will do. So you get the point of intersection by solving for... You get the point of intersection after plugging in these two separate equations. F of x is equal to... F of x is 1/4 sine pi x, and g of x is 4 to the power of negative x. So when you have a graphing calculator like mine, you will first find the y input section. There should be some area that you can use to input equations as y equals. So I'm going to plug in f of x and y of x into here. Formatting is slightly difficult to read on this, but as you can see, I have 1/4 plus sine pi x and 4 to the power of negative x here. What I'm going to do next is I'm going to go to the graph function, which is achieved on a TI-89 by pressing this little green diamond here, and graph, also known as F3. So in a few minutes, or actually maybe in a minute or less, we are going to have a graph. And this graph will show where our 2 points intersect. It's very tiny right now though, so you might want to zoom in order to find the intersection point. This TI-89 has this function to find the point of intersection, which is extremely convenient. Unfortunately, it has to regraph each time, so it will take a little bit of time to wait. But this should be good enough. You can see the point at which they intersect pretty distinctly, and this is one of my favorite parts about having a really good graphing calculator. You go to F5. F5 up here says math, but this button will not say math. But there is a number 5. So function number 5 will let you find the point of intersection between these two graphs. So select that. It will ask you what the first curve is. Then you ask you where the second curve is. Then you find the lower bound, or the area to the left of the point of intersection you are looking for. Then it asks you for the... Then you're going to look for the upper bound. The upper bound is to the right of the point of intersection. Let the calculator do its magic, and you find that the point of intersection is right there at 0.178x and 0.781y. So writing that down for future reference. That's the point of intersection. Now from here on, the rest of the problem is fairly easy. The first, part 1a, asks for you to find the area of R in orange. So we start by doing an integral. An integral with the top part of the curve minus the lower part of the curve, because technically this section R is area under the top curve minus the area under the bottom curve, which is here. It's a little difficult to see, admittedly. So the integral of that from 0 to x equals 0.178, because we're taking this in relation to the distance traveled on the x-axis, not the y-axis. From 0 to 0.178, the top function is 4 to the power of negative x. You know this because the graph of sine makes a sort of a wavelength, which this is. So 4 to the power negative x is your top function, minus 1/4 plus sine pi x. Put that in parentheses for clarification, times dx, because it is because you're going to be looking for the change in the x-coordinate. Once you have run this through your calculator, you will find that the answer this problem will go by a lot faster if you have a graphing calculator like I do. I have a TI-89, like Mr. Farrar. So this is a very integral heavy problem. So what you're going to need to do is find the integrate function on your graphing calculator. Up on the top screen, you'll see that I have a portion called Math, or Calc actually on mine. That's the F3 button, and then you're going to go see this entire list of all these functions that your nifty calculator can do for you. Go down one and you will find integrate, which gives you that fun little squiggly plus a parens. So from there, you're going to plug in the upper half equation, which is 4 to the power of negative x. This I'm going to enclose in parentheses so I can differentiate between them easily and so nothing gets jumbled on the calculator. So that's the top equation minus the bottom equation. The bottom equation is 1/4 plus sine of pi x. 4 to the power negative x minus 1/4 plus sine pi x. Now from here, you're going to specify on which range it's going to happen. In this case, from 0 to 0.178. So you do this by first off, don't you close off the parentheses yet. When you put in the integral first, you are going to get a little parentheses that says what's going to be inside the integral. You don't want to close it off yet. So without fully closing off the equation, you're going to put a comma, then whatever variable you're using, we're solving for x in this case, then another comma, and then you put whatever is on the bottom. In this case it is a 0. So comma x comma 0, comma again, and the end point, which is 0.178. And then you close it off with a parentheses. So now this comma x and the start and end points are inside of the integral. Hit enter, wait a little bit, and you will get 0.0647, which is going to be your area underneath this curve minus the area underneath this curve, or the area of your R function, or the area of R. So part A and part B look pretty similar except for the range at which you take the interval and in which equation's on top. So integral squiggly friend, bottom or left from which you take the integral, 0.178, and in your end point is 1, because AP test makers are friendly this time. So then you take the top half, top equation, not the top half, which is 1/4 plus sine pi x, parens. Parens are your friend. Minus the now bottom equation, which is 4 to the power of negative x dx. You always have to write your dx in here. I don't know if I said that earlier, but your dx is actually worth points on the AP exam, so you're always going to want to put your dx inside your integral. It's an easy point, guys. So you total that out with your handy dandy calculator, and you'll find that all this humble jumble means that the area of S equals .410. I think the AP test usually wants you to round to 3 decimal places. It's good, it's easy to remember. In this case, it's 0.41036 if you want to be really exact.